Okay, today's lesson is on stoichiometry. What is stoichiometry? Hang on. This word. Okay. Now, the spelling here is wrong. There should be a Chiometry. The I is missing. Stoichiometry. Oh, by the way, there is no 7.2. Okay, so earlier on we had 7.1, now we are 7.3. We don't have a 7.2. So what is stoichiometry? Now, stoichiometry is a ratio of quantities of substances measured in moles in a chemical reaction. So what do I mean by that? So for example, if you are making a sandwich, then you have one slice of ham, one slice of cheese, two slices of tomato, two slices of bread, and all of that will give you one sandwich. Then the ratio of ingredients can be represented as 1:1, 2:2, 2:1. Okay, that's a ratio. But now we are going to learn about ratios in chemistry equations, in chemistry reactions. So let's look at an example. So we have this equation, 2H2O plus O2 giving you 2H2O. So the balancing number 2, 1, 2. Nothing written in front of the oxygen means 1. So the 2 in front of the H tells us that there are 2 moles of H. Nothing written in front of oxygen means there's 1 mole of oxygen. And the 2 written in front of the water tells us that there's 2 moles of water. Therefore, we call this the mole ratio. Okay, so what is our mole ratio in this case? The mole ratio is 2:1:2. That's the theoretical ratio of how hydrogen and oxygen reacts in order to form water. Now, it is not the actual number of moles that is happening in the equation, right? It's not the actual number of moles. Anyway, we'll come to that later. Now, what we need to remind you is that the 2:1:2 is not telling us grams. It doesn't mean 2 gram is to 1 gram is to 2 grams. No. Okay? Because if we want to talk about grams, then we have to calculate mass. Now, this shows us mole. But if we want mass, how do we calculate mass? Then we have to think about the MR. Okay? So the first one, MR of hydrogen is actually equals to 2 times 1, which is 2. Okay? What's the MR of O2? MR of O2, this will be 2 times 16. So where did the 16 come from? Periodic table. Okay, that's what we did in 7.1. Then how about the MR of water? There will be H2, so there will be 2, plus 1 oxygen is 16, so this will be 18. Okay, but then we have the number out, the balancing number, right? If we are calculating mass, mass is equals to mole times MR. Okay, mass is equals to mole times MR. So if we want the actual mass, then we have to take mole, which is 2 for hydrogen, times the MR, which is 2, which means it's 4 grams. If we want the mass of oxygen, then it will be 1 times 32, which is 32 also. And if we want 2 moles of water, then it will be 2 take the mole, 2 times the MR. In this case, is 18. So that'll be 36. So if we are comparing mass, if we are talking about the ratio of mass, then the mass ratio will actually be, hang on, okay, ran off. So if it's the mass ratio, then it will actually be 4 grams of hydrogen, 32 grams of oxygen, and 36 grams of water, okay, based on our calculation from here. Okay, so if we are talking about mass, then it would be 4 grams is to 32 grams is to 36 grams. And what is the ratio in that case? Hey, the ratio is 1 is to 8 is to 9. It's different from moles. If you compare the on top here, the ratio of moles is 2 is to 1 is to 2. Whereas mass is 1 is to 8 is to 9. So the balancing number is not telling us the mass, it's telling us the mole. Okay? Now, the mass now leads us to something scientific called the law of conservation of mass. Mass is conserved in a reaction. What does that mean? It means that the total mass of a reactant must be equal to the mass of the products. What does that mean? So, what are the reactants? So, the hydrogen and the oxygen are the reactants. On the left-hand side of the equation is the reactants. On the right-hand side of the arrow, that will be the product. Okay, so that means that this 4 plus 32, these are the reactant. It'll be 4 plus 32 must be equal to the 36. This is our product. It's 36. So we say that this is mass is conserved. The total mass of the reactant is the same as the mass of the product. Okay? Right. Now, let's come to actually solving questions. That's the theory part. Now we come to actually solving questions. Now, we have to learn a method called MRU. What does MRU stand for? M stands for mole. R stands for ratio. And U stands for unknown. Okay, so let's just remember it as MRU. So, mole, step 1, find mole. That's the first one, M. Step 2, find ratio. What ratio? Mole ratio. Not mass ratio, mole ratio. And step 3, find unknown. Okay? So, sounds easy, right? MRU. Find mole, find ratio, find unknown. Keep that in mind. Let's look at the example. Now, this is how the question is worded. Calculate the mass of the solid obtained when 16.8 grams of sodium hydrogen carbonate is heated strongly until there is no further change. Okay, the first thing is, what is our unknown? What are we being asked to find? What are we asked to calculate? So the unknown is mass of the solid obtained. Right? This is our unknown. And what is our given information? What are we given to calculate with? We are given 16.8 grams of sodium hydrogen carbonate. And now we have the unit grams, all right? So gram is mass. And this is given. We are given this. Okay? Before we carry on, we need to revise. So what are the 5 formulas that we learned from 7.1? Can you still remember? Okay, write it all out now. Revise as we go along. There are 5 formulas, 4 mole and 1 concentration. Okay, so what are the 4 mole? Mole equals to mass over MR. Mole equals to volume of gas over 24 dm cubed. Mole equals to number of particles over 6.02. I always forget. 6.02 times 10 to the power 23. And then mole equals to concentration times volume of solution. Now, why must I write the volume of solution? Take note, there are two volumes, all right? One is volume of gas, another equation is volume of solution. So we have to be very clear which one we are trying to use. So that's our 4 mole formulas, and the last one is a concentration formula. Concentration will be equals to mass over volume of solution. That is if you are being asked for grams per dm cube. Okay, then this one will be grams, and this one will be dm cube. So these are our 5 formulas. 4 mole and 1 concentration. Right, now that we have got our question, we have to find what's the unknown in terms of the equation, all right? Calculate the mass of the solid obtained. Let's look at the solid obtained. This is a product. So the product is actually this one, okay? So this is our unknown. Then what are we given? Sodium hydrogen carbonate. This is sodium hydrogen carbonate, okay? And this is the 16.8 grams. Okay. So step one, find mole. So we are going to use the mass formula, mass over mR. Substitute in the numbers, 16.8 divided by, then calculate the mR of NaHCO3. That will give you 0.2 grams. First step done, find mole. Second step, find mole ratio from the equation. So what are we talking about? Ratio of what and what? So we have to see what are the two things that was mentioned in the equation. So one is the given information. The other one is the unknown, the one that we need to calculate. Yeah, write it out as a ratio. So the NaHCO3 has a 2 in front, so it's 2 moles. All right, there's a 2 in front. There's a 2 in front. So that will tell us it's 2 moles. The Na2CO3 has nothing in front, which means 1 mole. Correct? Then we substitute from step 1. In step 1, we found that the NaHCO3 is actually 0.2 moles. So we write that down. Okay, write that down. This is 0.2 moles. Therefore, then, what is the Na2CO3? Now, it's just a ratio. 2 becomes 1, so 0.2 will become 0.1. So, the number of moles of Na2CO3 now is 0.1. Okay? Next. Last step, calculate the unknown. Our unknown is Na2CO3. So, we'll take the mass formula. Mass is equal to mole times mR. Then we substitute in the numbers and we get our answer. Okay, so that is the example. Okay, that's the example that we are going to use. Okay, now let's try out question 1. Given a question like this, I'm not going to read, it's very long. How do we start to solve this question? So number 1, what is our unknown? What are we being asked to calculate? So this. Write down, this is unknown. What are we given? We're given 8 grams of copper 2 oxide. So this is given, and this is a mass. Okay? Now, where are these two things in the equation? Let's circle up these two things in the equation so that later on when we do ratio, we know which two things to take. So Al2O3 is here, and copper 2 oxide is here. Okay, so these are the two things, out of the four things in the equation, these are the two things that we will be taking note of. Okay, now we can start. So step 1. Step 1, find mole. Mole of what? Not the unknown. The unknown is the last step. So it must be mole of copper 2 oxide, the one where they give us a number. Alright, so find mole of CuO, the one where they actually give us a value. So they give us mass. So which mole formula are we going to use? We have to use the mass formula. What does the mass formula look like? Can you still remember? So mole will be equals to mass over MR. How much is this? Mass is 8 grams. That's what we are given. And MR of CuO, check periodic table, this will be 64 plus 16. Okay, and this is actually 8 divided by 80, which is 0.1 mole. So done. First step is done. This is CuO. We calculated in moles. Find moles already. Now step 2. Step 2, we need to find ratio. Step 2, find ratio of moles. Okay, so what is the mole ratio now? So which two things do we need to take the ratio of? It's the two things that we circled in the equation. Okay, so we circled CuO. So it's 3 CuO is to Al2O3, the two things that we circled. Then the ratio is therefore 3 moles is to 1 mole by looking at the balancing number. Alright, by looking at the balancing number, is 3 moles is to 1 mole. Hang on, so this is 3 CuO is to Al2O3. And it's 3 is to 1. Okay, now substitute from the step 1. In step 1, what did we calculate already? Okay, substitute from 1. So from 1, we know that CuO is actually 0.1 mole. Then how much is the aluminum oxide? That's what we want to find. So 3 becomes 1, so it's divided by 3. So 0.1 will become, we have to divide by 3 as well. So mole of Al2O3 will be equals to 0.1 divided by 3, which will be 0.0333. This is mole. Okay? So second step done. Now step 3, find unknown. So we are solving already. Find unknown. Okay, what is our unknown? Our unknown is actually aluminum oxide. Okay, and we want to find the mass. So mass of aluminum oxide. What's the formula to calculate mass? It will be mole times MR. And how much is this? 0.0333 times, now we have to go and find the MR. Aluminium is 27 times 2. That's aluminium. Plus oxygen is 16 times 3. this will be 0.0333 times, how much is this? 54.48. So this will be 102. And in the end, we'll get 3.4 grams. And we're done. Okay. Now, your job now is to try question 2. Right? Try question 2. Try it yourself. How can you solve this question? Follow the step in question 1. Follow the steps. So I'll start for you. All right. The first thing to do is, what's the unknown? What are we being asked to calculate? So how many kilograms of uranium? This is our unknown. Now find uranium in the equation. Which one is uranium? Is it UF4? No. All right. UF4 is uranium fluoride. So you only want uranium alone. So this is uranium. And what are we given? We are given 24 kilograms of magnesium, which is a mass. This is our unknown. Where is magnesium in our equation? Which one is magnesium? Magnesium is this one. Okay, magnesium is that one. Okay, now that you have done the groundwork, now I give you the layout. So number 1, find mole of magnesium. Not the unknown. There are only 2 things we are talking about. So not uranium, because uranium is the unknown. That's the last step. So it has to be the one where they give us a number. They give us 24 kilograms. So we know that 24 kilograms cannot be used. Mass has to be in grams. So 24 kilograms is actually how many grams? So this will be 24,000 grams. Okay, that's the first step. Try it out yourself. Pause this video and try it out yourself. Okay, so let me just show you how it will be done. Mole equals to mass over mR. So it will be 24,000 grams divided by mR of magnesium is a AR actually. So AR of magnesium will be 24. Find from periodic table. And this is actually 1,000 mole. Of magnesium. Just to remind us that this number belongs to magnesium. Okay, second step. Do you remember what's the second step? M, done already. R. R stands for what? MRU. So R stands for ratio. So what is the ratio? Okay, pause the video. Find it yourself. Pause the video. Okay, so this is now how it should be. So mole ratio will be equals to 2 mg is to U. This is from the equation, all right? Which means it's 2 mole is to 1 mole. Now you substitute from part 1. Substitute from 1. Magnesium is actually 1,000. So this is 1,000 mole. How much will be the uranium? So 2 becomes 1. So 1,000 will become 500. So that means that mole of uranium must be equals to 500 mole. Okay, 500 moles uranium. I'm just writing it out because just remember that 500 is uranium. Last step, find unknown. What is our unknown? Check our equation. Check our question again. What is our unknown? Our unknown is how many kilograms of uranium. So we need to find mass of uranium. Mass of uranium is equals to mole times mR. You rearrange the formula, you'll get mole times mR. How much do we get? 500 times 238. Find from periodic table. For uranium, okay? So this will be equals to 119000 grams. However, the question tells us that they want the answer in kilograms. Kilograms, so change it to kilogram. You have to divide by 1000. Divide by 1000, you get 119 kilograms. And that will be our final answer. Is that okay? Right, next example. Now, still the same thing, okay? Let's read the question. What is our unknown? What is the mass of iron produced? So this is our unknown. When 63 dm cube of carbon monoxide reacts. So this is our, now not mass anymore, huh? dm cube. dm cube is what quantity? Is it mass? It's not mass. dm cube is now volume. Okay, volume of gas. So this is volume of gas. Now, where are these two things in the equation? Circle up. Where are these two things in the equation? Iron is here. Carbon monoxide is here. Okay, iron and carbon monoxide. So it's these two. Out of the four things in the equation, we will be concentrating on only these two. Is that okay? The unknown and the one with the number. Okay, so the step is still the same. MRU method. Number 1, find mole of the given one. So given one will be the carbon monoxide, CO. Formula, this time is volume. So what's our volume formula? Volume of gas divided by 24 dm cube. This will be equals to 63 divided by 24, 2.625 mole. First step. Second step is the same as what we've been doing. Find mole ratio. Right, ratio of what two things? The two things that we circle up in the equation. So the two things that we circle up will be 3CO is to 2Fe. Okay, which means that this is 3 mole is to 2 mole. Now substitute from 1. So from 1, what was the number of moles that we calculated? So from 1, the CO is actually 2.625. Then how much is the iron? Okay, now it's not so obvious. All right, now it's not so obvious what number should be the iron. So now from maths, direct proportion, mole of iron will be equals to, take the 2.625 divided by 3 times 2. Okay, that's the ratio. 26. Okay, I tell you what, if you're not sure how to get this, can you write an extra step? All right, so what you do is you write an extra step. What is 1 mole? Will be how much? So if 3 moles is 2, 1 mole will be 2 divided by 3. Am I right? Okay, 3 moles is to 2. So if this is 1 mole, this will be 3 become 2, 1 will become divided by 3, 2/3. Then our question wants 2.625 mole. This will be how much? Then it will be the 2/3, 2 over 3 times 2.625. And this should give us 1.75 mole Fe. Okay, so whenever you get a number that's difficult to handle, always do this intermediate step. All right, put it as 1 mole. Then it will be clearer. And then number 3, same thing again, find unknown. Our unknown will be mass of iron, which is equals to mole times AR of iron. So you have to go and find from periodic table. 1.75, periodic table will be 56. This will be 98 grams. Okay, it's quite difficult, very complicated, but it's a structure, there's a system. If you learn up the system, it should be fine. Okay, we'll stop here for now.